Sarah Martinez had always been different from other girls in her neighborhood. While her friends spent their evenings watching television or chatting about boys, Sarah could be found in her father's garage, learning how engines worked or helping him fix broken appliances. Her father, Miguel, was a mechanic who had immigrated from Mexico 20 years earlier with nothing but a toolbox and determination to build a better life for his family. The garage was Sarah's sanctuary. The smell of motor oil and the sound of metal against metal felt more like home to her than the kitchen where her mother tried to teach her to cook traditional Mexican dishes. Not that Sarah didn't love her mother's cooking, but her hands seemed to understand wrenches better than wooden spoons. Her father noticed this early on and, despite his wife's protests that it wasn't proper for a young lady, he began teaching Sarah everything he knew about mechanics. By the age of 16, Sarah could diagnose engine problems just by listening to the sound a car made when it started. She understood the intricate dance of pistons, valves, and timing belts better than most professional mechanics twice her age. Her father would often joke that she had grease in her veins instead of blood, but there was pride in his voice when he said it. He had always wanted a son to carry on his trade, but Sarah proved that gender had nothing to do with mechanical aptitude. When Sarah graduated high school, she surprised everyone by announcing that she wanted to pursue mechanical engineering at the local community college while working part-time at her father's shop. Her guidance counselor, Mrs. Peterson, had tried to steer her toward more traditional fields like nursing or teaching, but Sarah's mind was made up. She knew where her talents lay, and she wasn't going to let anyone else's expectations dictate her future. College wasn't easy for Sarah. She was one of only 3 women in her mechanical engineering program, and the other 2 dropped out within the first semester. Her classmates, mostly young men who had grown up thinking they understood machines, often looked at her with skepticism. Some were outright dismissive, assuming she was there to find a husband rather than actually learn. Sarah learned to keep her head down and let her work speak for itself. Her professors, however, quickly recognized her exceptional abilities. Professor Williams, who taught advanced mechanics, often used Sarah's solutions as examples for the class. This didn't win her any friends among her male classmates, but Sarah didn't care. She wasn't there to make friends, she was there to learn and prove that she belonged in this field. During her second year, Sarah heard about an internship opportunity at Titan Industries, one of the largest construction companies in the region. Titan was known for taking on massive projects that other companies wouldn't touch. They built skyscrapers, bridges, and industrial complexes that required innovative engineering solutions. The internship was highly competitive, and, in the company's 50-year history, they had never hired a female intern in their engineering department. Sarah's application was initially overlooked. When she called to inquire about the status, the HR representative, assuming Sarah was a man based on the name alone, told her that all positions had been filled. It wasn't until Sarah showed up in person, dressed in her best suit and carrying a portfolio of her college projects, that they realized their mistake. The HR manager, clearly flustered, tried to explain that perhaps she would be better suited for their administrative internship program. Sarah politely but firmly requested to speak with the head of the engineering department. After waiting for 3 hours in the lobby, she finally got her chance to meet with James Crawford, Titan's chief engineer. Crawford was a man in his 50s who had built his reputation on solving impossible engineering challenges. He had a no-nonsense attitude and little patience for what he considered time-wasting. When Sarah walked into his office, Crawford looked up from his blueprints with barely concealed irritation. He had agreed to this meeting only because his HR department had insisted, and he wanted to get it over with quickly. Sarah, however, came prepared. She spread out her portfolio on his desk, showing him detailed drawings of a new type of crane mechanism she had designed for her advanced engineering class. The design was innovative, addressing several common problems with existing crane technology. Crawford studied the drawings in silence for several minutes. Despite his initial skepticism, he couldn't find any flaws in Sarah's work. The design was not only sound but showed a level of creative thinking that impressed him. He asked her several technical questions, expecting to trip her up, but Sarah answered each one with confidence and precision. By the end of the meeting, Crawford found himself genuinely interested in this young woman's ideas. However, tradition and company culture were strong forces at Titan Industries. Crawford explained to Sarah that while her work was impressive, the construction sites were rough environments not suitable for women. The men who worked there were used to a certain way of doing things, and introducing a female intern might cause problems. Sarah listened patiently to his concerns, then asked for just one chance to prove herself. Against his better judgment, Crawford agreed to give Sarah a trial period. He assigned her to work with Marcus Thompson, one of his most experienced foremen. Marcus was a 35-year-old man who had worked his way up from a basic laborer to supervising major construction projects. He was known for his practical approach to problem-solving and his ability to get the best work out of his crews. When Crawford informed Marcus that he would be working with a female intern, Marcus's reaction was predictable. He argued that construction sites were dangerous places where split-second decisions could mean the difference between life and death. Having to worry about protecting a woman would distract his crew from their work. Crawford understood Marcus's concerns but told him that the decision had been made and he was expected to give Sarah a fair chance. Sarah's first day at Titan Industries was memorable for all the wrong reasons. She arrived at the construction site at 6 in the morning, wearing work boots, jeans, and a hard hat, ready to prove herself. The project was a new office complex downtown, requiring precise coordination between multiple teams of workers. As soon as Sarah stepped onto the site, all work seemed to stop as the workers stared at her in surprise. Marcus introduced Sarah to the crew with obvious reluctance. He explained that she was an intern who would be observing their operations and possibly assisting with some basic tasks. The reactions ranged from amused chuckles to outright skepticism. One worker, a burly man named Frank, made a comment about the site not being a place for pretty girls to get their nails dirty. Sarah bit her tongue and focused on observing the work being done. The first week was a test of Sarah's patience and determination. She was assigned mostly menial tasks like organizing tools and fetching coffee, while the real engineering work was kept away from her. Marcus seemed to be waiting for her to complain or give up, but Sarah persevered. She used her time to study the construction process, asking questions and making notes about the equipment and procedures. It was during her second week that Sarah first encountered the machine that would later define her time at Titan Industries. The company had recently acquired a new industrial crane, a massive piece of equipment capable of lifting loads weighing several tons. The crane was supposed to revolutionize their operations, allowing them to move heavy materials more efficiently than ever before. However, there was a problem. The crane had been delivered with a critical component missing. The lifting mechanism that controlled the main arm had been damaged during shipping, and the replacement part was going to take 6 weeks to arrive from the manufacturer in Germany. This delay threatened to push back the entire project timeline, potentially costing Titan Industries hundreds of thousands of dollars in penalties and lost contracts. Crawford had assigned his best engineers to find a solution. They had spent days trying to devise a temporary fix or alternative approach, but nothing seemed to work. The crane was simply too heavy and complex to operate safely without the proper lifting mechanism. The team had even considered trying to modify existing equipment, but the risks were too great. Sarah had been observing these discussions from a distance, not yet trusted enough to be included in important engineering decisions. But every evening, she went home and thought about the problem. She studied the crane's specifications, researched similar equipment, and sketched possible solutions in her notebook. Her father, Miguel, often found her at the kitchen table late at night, surrounded by technical drawings and engineering manuals. One evening, while helping her father repair a hydraulic jack in their garage, Sarah had an inspiration. She realized that the principles they were using to lift the car could potentially be applied to the crane's lifting mechanism. It would require some creative engineering and precise calculations, but she believed it might work. The next morning, Sarah approached Marcus with her idea. He listened with barely concealed impatience as she explained her concept for a temporary hydraulic system that could replace the missing component. When she finished, Marcus shook his head and told her that the engineers had already considered hydraulic solutions and determined they wouldn't work. Sarah persisted, showing him her calculations and explaining how her approach was different from what had been previously attempted. Marcus, growing annoyed with what he saw as a stubborn intern who didn't understand her place, finally lost his patience. In front of the entire crew, he challenged Sarah directly. If she was so confident in her engineering knowledge, he said, then she should put her money where her mouth was. The crane's main counterweight, a massive steel block weighing over 3 tons, needed to be repositioned for maintenance. The team had been struggling with this task for days, unable to lift it safely with their available equipment. Marcus pointed to the counterweight and made his challenge clear. If Sarah could figure out how to lift that massive piece of steel when the entire experienced crew had failed, then maybe her ideas about fixing the crane were worth considering. If she couldn't, then she should accept that she didn't belong on a construction site and find a different internship. The crew gathered around to watch, some snickering at what they saw as an impossible challenge. The counterweight was enormous, far beyond what any conventional lifting equipment on site could handle safely. Sarah looked at the steel block, her mind racing through possibilities and calculations. She knew that this moment would define not just her internship, but potentially her entire career in engineering. Standing there in front of the skeptical faces of her co-workers, Sarah felt the weight of every doubt that had ever been expressed about her abilities. This wasn't just about lifting a piece of steel. It was about proving that she belonged in a world that had never welcomed women. She thought about her father's encouragement, about the countless hours she had spent learning her craft, and about the dreams she had carried since childhood. Marcus crossed his arms and waited, confident that this young woman would finally realize she was in over her head. The other workers placed bets on how quickly Sarah would back down from the challenge. But they didn't know Sarah Martinez. They didn't know about the determination that had driven her to excel in every engineering class, or the creativity that came from years of solving problems in her father's garage. Sarah took a deep breath, walked over to the counterweight, and began examining it from every angle. She was studying not just the weight itself, but the entire environment around it. She looked at the ground conditions, the available anchor points, the positioning of other equipment, and the space available for maneuvering. Her mind was already working through the physics of the problem, considering leverage, distribution of forces, and creative applications of the equipment available on site. The crew watched in fascination as Sarah methodically examined every aspect of the situation. Some began to realize that she wasn't just looking at the problem randomly, but was conducting a systematic engineering analysis. Marcus, despite his skepticism, found himself curious about what she was thinking. Even Crawford, who had heard about the challenge, came down from the site office to observe. As Sarah continued her examination, she began to see possibilities that others had missed. The solution wouldn't be simple, and it would require precise coordination and innovative thinking. But she believed it could be done. The question was whether she could convince the crew to trust her unconventional approach and whether her calculations were correct. One mistake could be dangerous, expensive, or both. The stage was set for a moment that would change everything at Titan Industries. Sarah had accepted Marcus's challenge, but now she had to deliver results. The eyes of every worker on the site were on her, waiting to see if the young woman who claimed to understand engineering could actually solve a problem that had stumped their entire experienced team. Sarah spent the next hour walking around the construction site, not just looking at the counterweight, but studying every piece of equipment available. She examined the mobile cranes, the hydraulic lifts, the pulley systems, and even the construction vehicles. The workers initially followed her around, making jokes about how she was just buying time before admitting defeat. But, as time passed, their mocking comments became quieter as they realized she was genuinely working on something. Marcus had expected Sarah to give up within the first few minutes. When she didn't, he began to worry that she might actually attempt something dangerous just to prove her point. He approached her after she had been examining a combination of equipment near the counterweight for 20 minutes. "Look, Sarah," he said, trying to sound reasonable, "there's no shame in admitting this is beyond what you can handle. The weight is just too much for the equipment we have available." Sarah looked up from her notebook where she had been making calculations. "I understand your concern, Marcus, but I think I see a way to make this work. It's not about brute force, it's about understanding physics and using mechanical advantage properly." She showed him her sketches, explaining how she planned to use a combination of the site's equipment in a way that none of them had considered. Her plan involved creating a compound pulley system using the mobile crane as an anchor point, combined with hydraulic jacks to provide additional lifting force at strategic points. She would use the principle of mechanical advantage to multiply the available lifting capacity, essentially turning the entire setup into one large, coordinated lifting machine. The counterweight would be lifted gradually and safely, with multiple safety points to prevent accidents. Marcus studied her drawings with growing interest. Despite his initial skepticism, he had to admit that her approach was technically sound. The mathematics checked out, and her understanding of the physics involved was impressive. However, the execution would require precise coordination and trust from his entire crew. One person making a mistake could result in the counterweight falling and potentially injuring or killing someone. Even if this could work theoretically, Marcus said, coordinating all these different systems simultaneously would be incredibly complex. My crew isn't trained for this kind of operation. It's too risky. Sarah nodded, understanding his concerns about safety. That's why we'll do it in stages, she explained. We'll test each component separately first, then combine them gradually. Every step will have multiple safety backups. Word of Sarah's plan had spread throughout the construction site. Workers from other areas began gathering around to see what was happening. Crawford himself came down from the main office, having heard about the situation. He looked at Sarah's calculations and drawings, asking several detailed technical questions. Despite his reservations about the entire situation, he couldn't find any obvious flaws in her engineering. The challenge had evolved beyond a simple test of Sarah's abilities. It had become a matter of professional reputation for everyone involved. If Sarah succeeded, it would demonstrate that a young woman intern had solved a problem that had stumped experienced construction workers. If she failed, it would confirm the skeptics' belief that she didn't belong in this environment. Crawford made the decision to allow Sarah to attempt her solution, but with strict safety protocols. Every worker involved would wear additional safety equipment, and the lifting area would be cleared of all unnecessary personnel. They would proceed slowly and stop immediately if any aspect of the operation seemed unsafe. Marcus was assigned to oversee the entire process and had the authority to halt everything if he felt the risks were too great. Preparing for the lift took most of the afternoon. Sarah worked with the crane operator to position the mobile crane exactly where she needed it. She supervised the placement of hydraulic jacks at specific points around the counterweight, ensuring that each one was on solid ground and properly calibrated. The pulley systems had to be rigged with precision, with every cable and connection checked multiple times. The crew, initially skeptical of taking orders from a young woman, gradually began to respect Sarah's thorough approach to safety and her obvious understanding of the equipment. She didn't just tell them what to do, she explained why each step was necessary and how it contributed to the overall safety of the operation. Her confidence was infectious, and even the most doubtful workers began to believe that her plan might actually work. Frank, the burly worker who had made the comment about pretty girls on the first day, found himself assigned to operate one of the hydraulic jacks. He approached Sarah with a question about the pressure settings, and she patiently explained not just what to do, but why those specific settings were important for safety. By the end of their conversation, Frank was calling her boss with genuine respect. As the sun began to set, everything was finally in position. Sarah had triple-checked every connection, every calculation, and every safety protocol. The counterweight sat surrounded by a carefully orchestrated arrangement of lifting equipment that looked more like a complex engineering experiment than a construction operation. The entire crew gathered at a safe distance to watch, with Crawford and Marcus standing closest to monitor the proceedings. Sarah took a final walk around the setup, checking everything one more time. She could feel the weight of everyone's expectations, but also the confidence that came from thorough preparation and solid engineering. Her father had always taught her that good preparation was the key to solving any mechanical problem. This was just a much larger version of the projects they had worked on together in their garage. The lifting process began slowly and methodically. Sarah coordinated the operation from a central position where she could see all the equipment and communicate with each operator. She started with the hydraulic jacks, gradually applying pressure to lift one edge of the counterweight just a few inches off the ground. The massive steel block shifted slightly, and everyone held their breath. Next came the pulley system. The crane operator followed Sarah's signals precisely, applying tension gradually and evenly. The cables tightened, and the counterweight began to rise more noticeably. The coordination required was intense, with Sarah constantly monitoring the stress on every component and adjusting the lifting forces accordingly. Marcus watched nervously as the operation progressed. He had to admit that Sarah's approach was working, but the complexity of coordinating so many different systems made him anxious. One miscommunication or equipment failure could still result in disaster. However, he was impressed by Sarah's calm professionalism and clear communication with each crew member. As the counterweight rose higher, the crowd of watching workers grew larger. Word had spread throughout the construction site and even to other Titan Industries projects nearby. People were arriving just to see if the young woman intern could actually accomplish what she had claimed. The pressure was enormous, but Sarah remained focused on the technical aspects of the operation. When the counterweight reached a height of 3 feet, Sarah called for a pause. This was a critical point where the stresses on the equipment would be at their highest. She walked around the entire setup again, checking every cable, every hydraulic connection, and every anchor point. Everything looked stable and secure. The plan was working exactly as she had calculated. The final phase involved rotating the counterweight to its new position while keeping it suspended in the air. This required even more precise coordination, as the center of gravity would shift during the rotation. Sarah had planned for this, but executing it required trust and teamwork from every person involved in the operation. Gradually, carefully, the massive steel block was maneuvered into its new position. The entire process took nearly 2 hours, but every minute was executed with precision and safety. When Sarah finally gave the signal to lower the counterweight into its final position, the watching crowd held their breath. The hydraulic jack slowly released pressure, the crane cables went slack, and the 3-ton counterweight settled perfectly into place. For a moment, there was complete silence on the construction site. Then, someone started clapping, and, within seconds, the entire crowd erupted in applause. Workers who had been skeptical of Sarah just hours earlier were now cheering for her accomplishment. She had not only solved the problem but had done it safely and professionally. Marcus walked over to Sarah, extending his hand with a genuine smile. "I owe you an apology," he said. "I was wrong about you, and I was wrong about what you could accomplish. That was some of the finest engineering work I've ever seen." Other crew members gathered around to congratulate Sarah, many admitting that they had never seen such an innovative solution to a mechanical problem. Crawford approached Sarah with a more measured response, but his approval was clear. "That was impressive work," he told her. "Your approach was creative, safe, and effective. You've proven that you understand both the theoretical and practical aspects of engineering." He paused, then added, "I think it's time we talked about giving you some real engineering responsibilities on this project." The success with the counterweight changed Sarah's status on the construction site completely. Workers who had previously ignored her now sought her opinion on technical problems. Marcus began including her in engineering discussions and giving her meaningful assignments. However, the biggest change was in how Sarah viewed herself and her capabilities. That evening, Sarah called her father to tell him about what had happened. Miguel listened with pride as his daughter described the challenge, her solution, and the successful outcome. "I knew you could do it, Nija," he said. "You have always had the mind of an engineer and the heart of a fighter. Today you proved that to everyone else." But Sarah's triumph with the counterweight was only the beginning of her story at Titan Industries. The damaged crane still needed to be repaired, and her original idea about creating a temporary hydraulic lifting system had not been forgotten. Crawford had been impressed enough with her problem-solving abilities that he was now willing to consider her proposal for fixing the crane seriously. The next morning, Sarah was invited to a meeting with Crawford and the senior engineering team. They wanted to hear her ideas about the crane repair in detail. This was the opportunity she had been waiting for since starting her internship, the chance to prove that she could contribute to solving major engineering challenges. Sarah arrived at the meeting prepared with detailed drawings, calculations, and a list of materials that would be needed for her proposed solution. She had spent the entire previous evening refining her ideas and preparing for the technical questions she knew would come. This meeting would determine whether she would be treated as a serious contributor to the project or remain just an intern doing basic tasks. The conference room was filled with Titan Industries' most experienced engineers, men who had decades of experience in construction and mechanical engineering. As Sarah spread out her drawings and began explaining her proposal, she could see the skepticism in some faces, but also genuine interest in others. She had learned that earning respect in this environment required proving herself repeatedly, but yesterday's success had given her the confidence to present her ideas boldly. Her proposal for repairing the crane was indeed innovative. Instead of waiting 6 weeks for the replacement part from Germany, she suggested building a temporary hydraulic system that could provide the same lifting capability using readily available components. The system would be more complex than a simple replacement, but it could be built and installed within a week using local suppliers and the company's existing equipment. Crawford listened intently as Sarah explained the technical details of her proposal. Her understanding of hydraulics, mechanical stress, and safety systems was impressive for someone so young and relatively inexperienced. However, the crane represented a significant investment for the company, and any modifications would need to be absolutely reliable and safe. The concept is sound, Crawford admitted after Sarah finished her presentation, but implementing it on such a critical piece of equipment carries significant risks. If something goes wrong with a temporary modification, we could be looking at equipment damage, project delays, and potentially serious safety issues. The other engineers nodded in agreement, recognizing both the innovation and the risks in Sarah's proposal. Sarah had anticipated these concerns and was ready with responses. She proposed building and testing the hydraulic system separately before installing it on the crane. They could simulate the loads and stresses it would face, identify any potential problems, and refine the design before committing to the installation. Additionally, the temporary system could be designed with multiple redundant safety features to minimize risks. The discussion continued for over an hour, with various engineers raising technical questions and potential problems. Sarah answered each question confidently, demonstrating that she had thought through every aspect of the proposal. However, she also showed wisdom by admitting when she wasn't certain about something and suggesting how additional research or testing could address those uncertainties. By the end of the meeting, Crawford had made his decision. He would authorize Sarah to build a prototype of her hydraulic system, working under the supervision of Marcus and the senior engineering team. If the prototype proved successful and safe, they would consider installing it on the crane. It was a significant opportunity for Sarah, but also a major responsibility that would test her abilities in new ways. The project would require Sarah to work with suppliers, coordinate with different departments within Titan Industries, and manage a small team of technicians and mechanics. These were skills that went beyond pure engineering, involving project management, communication, and leadership abilities. For someone who had started as a skeptically received intern just weeks earlier, it represented a remarkable advancement in responsibility and trust. Sarah's new project began immediately the next morning. Crawford had assigned her a small workspace in one of the maintenance buildings where she could build and test her hydraulic prototype. Along with the space, she was given a budget for materials and the assistance of 2 experienced mechanics, Tom and Roberto, who would help with the actual construction and testing. Tom was a veteran mechanic in his late 40s who had worked for Titan Industries for over 20 years. He was initially skeptical about taking orders from a young woman, especially one who was still technically an intern. Roberto, younger and more open-minded, was curious about Sarah's ideas and eager to learn new techniques. The dynamic between the three of them would be crucial to the project's success. Sarah's first challenge was earning the respect and cooperation of her 2 assistants. She knew that her technical knowledge alone wouldn't be enough. She needed to demonstrate leadership skills and practical problem-solving abilities. She began by sitting down with Tom and Roberto to explain not just what they were going to build, but why each component was necessary and how the overall system would work. Tom listened with the patience of someone who had heard many engineering theories over the years, most of which didn't work well in practice. However, as Sarah explained her design, he began to recognize that her approach was grounded in practical experience, not just textbook knowledge. She understood the limitations of real-world equipment and had designed her system accordingly. The hydraulic prototype needed to demonstrate that it could safely lift loads equivalent to what the damaged crane component was designed to handle. This meant creating a test setup that could simulate the stresses and operating conditions the actual crane would face. Sarah's design called for a combination of hydraulic cylinders, pressure regulators, and safety valves that would work together to provide precise lifting control. Building the prototype required sourcing components from multiple suppliers around the city. Sarah found herself spending hours on the phone with hydraulic equipment vendors, explaining her requirements and negotiating prices. This was a new experience for her, requiring skills in communication and business that she hadn't learned in engineering classes. One supplier, Peterson Hydraulics, initially refused to sell to Sarah directly when they learned she was a young woman working on what they considered an experimental project. They insisted on dealing with a senior engineer or project manager from Titan Industries. Sarah's first instinct was to ask Crawford to intervene, but she realized this would undermine her credibility and independence. Instead, she invited the supplier's representative to visit their workshop and see the project firsthand. When Jim Peterson, the owner of Peterson Hydraulics, arrived at the workshop, he expected to find an amateur project that would waste his company's expensive equipment. Instead, he found a meticulously organized workspace with detailed engineering drawings and a clear project plan. Sarah walked him through her design step by step, explaining the technical requirements and safety considerations with obvious expertise. Peterson was impressed despite his initial prejudices. Sarah's knowledge of hydraulic systems was comprehensive, and her questions about component specifications were precisely the right ones. By the end of his visit, he was not only willing to supply the needed equipment but was offering technical advice and suggesting improvements to her design. Sarah had won over another skeptic through competence and professionalism. As construction of the prototype began, Sarah discovered that managing a technical project involved much more than just engineering. She had to coordinate delivery schedules, manage the project budget, and solve unexpected problems that arose during construction. When one critical component arrived damaged, she had to quickly find an alternative supplier while staying within budget and timeline constraints. Tom proved to be invaluable during this phase of the project. His decades of experience had taught him which suppliers were reliable, which shortcuts were safe, and how to work around the inevitable problems that occurred in any construction project. He also began teaching Sarah practical skills that couldn't be learned from books, like how to properly install hydraulic fittings and troubleshoot system problems. Roberto brought energy and enthusiasm to the project. He was fascinated by Sarah's innovative approach and eager to learn new techniques. His willingness to try unconventional solutions complemented Tom's practical experience and Sarah's theoretical knowledge. The three of them gradually developed an effective working relationship based on mutual respect and shared goals. The prototype took 2 weeks to build and another week to test thoroughly. Sarah insisted on extensive testing because she knew that the success of her design would be judged not just on whether it worked, but on whether it worked safely and reliably under various conditions. They tested the system with different load weights, in different weather conditions, and under various stress scenarios. During one test, a hydraulic line developed a small leak under high pressure. Tom wanted to simply replace the fitting and continue testing, but Sarah insisted on understanding why the failure had occurred. They discovered that the pressure spike causing the leak was due to a design flaw in her control system. Sarah redesigned that portion of the system, adding a pressure relief valve that would prevent similar problems in the future. This attention to detail and willingness to admit and correct mistakes earned Sarah even more respect from Tom and Roberto. They had worked with many engineers over the years who were more concerned with proving they were right than with building something that actually worked reliably. Sarah's approach was refreshingly different and practical. The testing phase also revealed several ways to improve the system's efficiency and safety. Sarah incorporated these improvements into her design, creating a final version that was significantly better than her original concept. This iterative process of testing, learning, and improving was exactly what Crawford had hoped to see from the project. When the prototype testing was complete, Sarah prepared for the demonstration that would determine whether her hydraulic system would be approved for installation on the actual crane. Crawford had invited several senior engineers from other Titan Industries projects to observe the demonstration, making it a high-stakes event that would influence not just this project but Sarah's future with the company. The demonstration was scheduled for a Friday morning, giving Sarah and her team time to prepare the prototype and create a comprehensive presentation. Sarah spent the evening before the demonstration reviewing every aspect of the system, checking calculations, and preparing for the technical questions she knew would come from the experienced engineers who would be watching. On the morning of the demonstration, the maintenance building was filled with more people than Sarah had expected. In addition to the engineers Crawford had invited, many of the construction workers from various projects had come to see how the young woman's hydraulic system performed. Word had spread throughout the company about Sarah's innovative approach to solving the crane problem. Sarah began the demonstration with a detailed explanation of her system, using charts and diagrams to show how each component worked and how they functioned together. She explained the safety features, the control mechanisms, and the testing procedures that had proven the system's reliability. Her presentation was professional and comprehensive, covering every aspect that experienced engineers would want to understand. The actual demonstration of the hydraulic system exceeded everyone's expectations. The prototype lifted load smoothly and precisely, responding accurately to control inputs and maintaining perfect safety throughout the operation. The system handled various load weights without difficulty, and the safety systems functioned exactly as designed when Sarah deliberately triggered them to show their effectiveness. Questions from the observing engineers were detailed and challenging, but Sarah was prepared for each one. She had anticipated most of their concerns and had test data to support her answers. When one engineer questioned the system's performance under extreme conditions, Sarah showed him the results of stress testing that demonstrated safe operation even beyond normal operating parameters. Tom and Roberto assisted with the demonstration, operating different parts of the system and answering questions about the construction process. Their obvious confidence in Sarah's design and their enthusiastic support for the project influenced the observing engineers significantly. These were experienced mechanics whose opinions carried weight, and their endorsement of Sarah's work was valuable. By the end of the demonstration, Crawford was ready to approve installation of the hydraulic system on the actual crane. The prototype had proven that Sarah's design was not only technically sound but practical and safe for real-world use. However, he wanted to proceed cautiously, installing the system in stages and testing it thoroughly before putting it into full operation. The success of the demonstration marked another major milestone in Sarah's journey at Titan Industries. She had moved from being a skeptically received intern to leading a successful engineering project that would save the company significant time and money. However, she knew that installing the system on the actual crane would present new challenges and pressures. That afternoon, Crawford called Sarah into his office for a private conversation about her future with the company. He explained that her work on the hydraulic system had impressed not just him but senior management throughout Titan Industries. They were offering her a full-time position as a junior engineer, with the opportunity to work on major projects and continue developing her innovative approaches to engineering problems. Sarah was thrilled with the job offer, but she also understood the responsibilities that would come with it. She would be one of the youngest engineers in the company and certainly the only woman in the engineering department. The pressure to prove herself would be constant, and any mistakes would be scrutinized more closely than those of her male colleagues. Over the weekend, Sarah discussed the job offer with her parents. Miguel was proud of his daughter's accomplishments but worried about the challenges she would face as the only woman in a male-dominated environment. Her mother, Carmen, was concerned about the physical demands and potential dangers of construction work. However, both parents recognized that this opportunity was exactly what Sarah had been working toward. Sarah accepted the job offer on Monday morning, but her celebration was brief because she immediately had to begin planning for the installation of her hydraulic system on the actual crane. This would be far more complex than building and testing a prototype, requiring coordination with crane manufacturers, safety inspectors, and multiple departments within Titan Industries. The crane installation project would test all of Sarah's abilities as an engineer, project manager, and leader. Success would establish her reputation within the company and the broader construction industry. Failure could end her career before it really began. The stakes were higher than ever, but Sarah was ready for the challenge. Marcus, who had initially challenged Sarah about lifting the counterweight, was assigned to oversee the crane installation project. This created an interesting dynamic, as Marcus would now be working for someone who had originally been his intern. However, his respect for Sarah's abilities had grown significantly, and he was committed to supporting her success. The first step in the installation process was obtaining approval from the crane manufacturer and relevant safety authorities. Sarah's hydraulic system would be modifying equipment that was certified for specific operating parameters, and any changes required extensive documentation and approval processes. This bureaucratic aspect of engineering was new to Sarah, but it was essential for legal and safety reasons. Sarah spent several days preparing detailed engineering drawings, safety analyses, and installation procedures that would satisfy regulatory requirements. She worked closely with Titan Industries' legal department to ensure that all modifications would be properly documented and approved. This process was tedious but necessary for protecting both the company and the workers who would operate the modified crane. The regulatory approval process took longer than expected, with safety inspectors requiring additional documentation and testing data. Sarah had to demonstrate not just that her system would work, but that it would work safely under all possible operating conditions. This meant additional testing of the prototype and more detailed analysis of stress factors and failure modes. During this waiting period, Sarah used the time to refine her installation procedures and train the mechanics who would assist with the actual installation. She created detailed checklists and safety protocols that would guide every aspect of the installation process. Her thorough preparation reflected the lessons she had learned about the importance of planning and safety in successful engineering projects. When regulatory approval finally came through, Sarah was ready to begin the installation immediately. The process would take several days and require shutting down other operations in the area around the crane. The pressure to complete the installation quickly and correctly was intense, as any delays would affect multiple projects and cost the company significant money. The installation began on a Monday morning with Sarah supervising a team of 6 mechanics and technicians. Every step was carefully documented, with photographs and checklists confirming that each procedure was completed correctly. Sarah's attention to detail and systematic approach impressed everyone involved in the installation process. Midway through the second day of installation, a problem emerged that Sarah had not anticipated. The mounting points for her hydraulic system were slightly misaligned with the crane's structure, creating stress concentrations that could lead to failures. Sarah had to quickly redesign the mounting system to distribute the loads properly while staying within the approved parameters for the installation. The mounting alignment problem threatened to derail the entire installation project. Sarah had 2 choices: halt the installation while she redesigned the mounting system properly, or attempt a field modification that might work but carried unknown risks. The pressure to continue was enormous, as stopping the installation would delay the project by weeks and cost Titan Industries thousands of dollars per day. Sarah called a meeting with Marcus, Crawford, and the installation team to discuss the options. She explained the technical problem clearly, outlining the risks associated with each possible solution. Crawford was frustrated by the unexpected complication, but he appreciated Sarah's honest assessment of the situation rather than an attempt to minimize the problem. "What do you recommend?" Crawford asked, putting the decision squarely on Sarah's shoulders. She took a deep breath before responding. "We should halt the installation and redesign the mounting system properly. I know it will cost time and money, but the risks of a field modification are too great. If the mounting fails under load, we could lose the entire crane and possibly injure workers." Marcus nodded in agreement, remembering how Sarah had prioritized safety over speed during the counterweight lifting operation. "She's right," he told Crawford. "We've seen what happens when people try to rush engineering modifications. Better to do it right the first time." Crawford was disappointed but approved Sarah's recommendation to halt the installation. Redesigning the mounting system required Sarah to work with the crane manufacturer's engineers to understand the structural limitations and requirements. This involved several conference calls with technicians in Germany, complicated by time zone differences and language barriers. Sarah's persistence and clear communication eventually resulted in a collaborative solution that satisfied everyone's requirements. The new mounting design was more complex than Sarah's original concept, requiring additional components and more precise installation procedures. However, it would distribute loads more evenly and provide better long-term reliability. Sarah spent 3 days refining the design and updating all the installation procedures and safety protocols. During the design revision period, Sarah faced criticism from some within Titan Industries who questioned whether the delays were worth the potential benefits of her hydraulic system. A few senior managers suggested abandoning the project and simply waiting for the original replacement part from Germany. This criticism was particularly difficult for Sarah because she knew that, as the only woman engineer in the company, her failures would be remembered longer and more clearly than her successes. Crawford supported Sarah's decision to redesign rather than compromise on safety, but he made it clear that the revised installation had to proceed flawlessly. There would be no tolerance for additional delays or problems. Sarah understood that her future at Titan Industries depended on the success of this project, but she also knew that rushing to meet arbitrary deadlines could lead to exactly the kind of problems they were trying to avoid. The revised installation began 2 weeks later with Sarah leading a slightly larger team that included specialists from the crane manufacturer. Every component had been pre-tested, and every procedure had been reviewed multiple times. Sarah's preparation was so thorough that the installation proceeded without any significant problems, completing successfully in just 3 days. Testing the completed hydraulic system on the actual crane was both exciting and nerve-wracking for Sarah. All of her calculations and prototype testing had indicated that the system would work perfectly, but there's always uncertainty when moving from controlled test conditions to real-world operations. The first test lifts were performed with light loads and gradually increased as the system proved its reliability. The crane's performance with Sarah's hydraulic system exceeded all expectations. The lifting control was more precise than the original equipment had provided, and the safety systems responded perfectly to various test scenarios. The system handled the crane's maximum rated load without any stress indicators or operational problems. Sarah had not only solved the original problem but had actually improved the crane's capabilities. Word of the successful crane repair spread quickly throughout Titan Industries and the broader construction industry. Engineering magazines requested interviews with Sarah about her innovative approach to hydraulic system design. Other construction companies inquired about licensing her design for their own equipment. At age 19, Sarah had become a recognized expert in industrial hydraulic systems. However, the success of the crane project was just the beginning of Sarah's challenges at Titan Industries. As a full-time engineer, she was assigned to work on a variety of projects that tested different aspects of her abilities. Some colleagues genuinely respected her skills and sought her input on technical problems. Others remained skeptical and looked for opportunities to prove that her early successes were just lucky accidents. Sarah's first major project as a full-time engineer involved designing a foundation system for a new high-rise building on unstable soil conditions. The geological survey had revealed that the construction site had underground water flow patterns that could undermine traditional foundation designs. Previous engineering consultations had suggested expensive solutions that would significantly increase the project's cost and timeline. Sarah approached the foundation problem with the same systematic methodology she had used for the crane repair. She studied geological reports, researched similar construction projects, and consulted with soil engineering specialists. Her analysis revealed that previous engineers had been overly conservative in their estimates of soil instability, leading to unnecessarily expensive foundation requirements. Her proposed foundation design used a combination of deep pilings and soil stabilization techniques that would provide the necessary structural support at significantly lower cost than previous proposals. The design was innovative but based on well-established engineering principles adapted to the specific conditions of the construction site. Presenting her foundation design to Titan Industries senior management was another test of Sarah's ability to communicate complex technical concepts to business-focused decision-makers. She prepared presentations that explained not only how her design would work but why it would be more cost-effective than alternatives. Her analysis showed potential savings of over $2 million compared to the previously recommended approach. The foundation project approval process was more complex than the crane repair because it involved external investors and regulatory authorities who had to approve any deviation from standard construction practices. Sarah found herself presenting her design to city planning committees, investor groups, and independent engineering consultants who all needed to understand and approve her innovative approach. Some of these presentations were challenging because the audiences included people who were skeptical of non-traditional approaches to construction. Sarah learned to address their concerns directly while maintaining confidence in her technical analysis. Her ability to explain complex engineering concepts in simple, understandable terms served her well in these situations. The foundation project was approved after a 6-week review process, and construction began under Sarah's direct supervision. Managing a major construction project was different from building prototypes or repairing equipment because it involved coordinating multiple contractors, managing supply chains, and ensuring compliance with numerous regulations and safety requirements. Sarah's approach to project management reflected her engineering background, emphasizing systematic planning, clear communication, and continuous monitoring of progress and quality. She insisted on regular meetings with all contractors to review progress and address problems before they became serious. Her attention to detail and proactive approach prevented several potential delays and cost overruns. During the foundation construction, Sarah encountered her first major crisis as a project engineer. Heavy rains caused flooding in the excavation area, threatening to undermine the soil stabilization work that had already been completed. Traditional approaches to this problem would require pumping out the water and starting over, adding weeks to the project timeline and hundreds of thousands of dollars to the cost. Sarah worked through the weekend to develop an alternative approach that would allow construction to continue despite the water infiltration. Her solution involved modifying the planned drainage system to handle the excess water while actually strengthening the overall foundation structure. The modification required approval from regulatory authorities and coordination with multiple contractors, all while work continued in difficult conditions. The crisis management required Sarah to demonstrate leadership skills beyond pure technical knowledge. She had to convince skeptical contractors to try her unconventional approach while managing the concerns of senior management who were worried about project delays and cost overruns. Her calm professionalism and clear communication helped maintain confidence in her solution during a stressful period. The modified foundation design worked exactly as Sarah had predicted, actually completing ahead of schedule despite the weather-related complications. The project's success enhanced her reputation throughout the company and the construction industry. By her second year at Titan Industries, Sarah was being consulted on technical problems across multiple projects and was considered one of the company's most valuable engineering assets. Sarah's success led to opportunities beyond Titan Industries. She was invited to speak at engineering conferences, serve on industry committees, and consult on projects for other companies. However, she remained committed to Titan Industries, where she felt she could continue to grow and take on increasingly challenging projects. As Sarah's career progressed, she never forgot the lessons learned from Marcus's challenge about lifting the counterweight. That experience had taught her that proving herself required more than just technical knowledge, it required persistence, creativity, and the willingness to take calculated risks. Every subsequent project reinforced these lessons and built her confidence in her ability to solve complex engineering problems. The young woman who had started as a skeptically received intern had become one of the most respected engineers in the construction industry. Sarah's journey demonstrated that excellence and determination could overcome prejudice and stereotypes, but it also showed that success required continuous learning, adaptation, and the willingness to face new challenges with confidence and creativity. Sarah's influence extended beyond her individual projects to the culture of Titan Industries itself. Her success encouraged the company to recruit more women into engineering roles and to evaluate job candidates based on ability rather than traditional assumptions about gender roles. Several young women engineers joined the company specifically because of Sarah's example and mentorship. 5 years after starting as an intern, Sarah was promoted to senior project engineer with responsibility for some of Titan Industries' most challenging and innovative construction projects. She had developed expertise in multiple areas of engineering and was known throughout the industry for her creative problem-solving abilities and uncompromising commitment to safety and quality. Looking back on her journey from that first day when she was assigned to fetch coffee, Sarah recognized that every challenge had contributed to her development as both an engineer and a leader. The skepticism she had faced had motivated her to excel, and the obstacles had taught her valuable lessons about persistence and professional growth. Marcus, who had issued the original challenge about lifting the counterweight, became one of Sarah's strongest supporters and closest collaborators. He often told new employees the story of how a young intern had solved a problem that had stumped his entire experienced crew, using it as an example of why it was important to listen to new ideas regardless of their source. Sarah's story became part of the culture at Titan Industries, inspiring other young engineers to pursue innovative solutions and approach problems with creativity and confidence. Her example showed that technical excellence, combined with determination and professional integrity, could overcome any barrier and achieve remarkable success. The crane that Sarah had repaired with her innovative hydraulic system continued to operate successfully for many years, becoming a symbol within the company of what could be accomplished through creative engineering and careful execution. New employees were often shown the crane and told the story of how a young woman intern had saved a major project through her technical skills and determination. As Sarah's career continued to advance, she remained grateful for the challenge that Marcus had issued on that day when she was still trying to prove herself. That moment had forced her to demonstrate her abilities under pressure and had led to opportunities she might never have received otherwise. It had taught her that sometimes the most difficult challenges provide the greatest opportunities for growth and success. The young woman who had grown up learning about engines in her father's garage had become a leader in one of the most traditionally male-dominated industries. Her journey from intern to senior engineer demonstrated that with sufficient determination, skill, and courage, anyone could achieve their goals regardless of the obstacles and skepticism they might face along the way.